An electric current of 5 amps flows through a hairdryer that has a resistance of 75 ohms. What power does the hairdryer radiate? Can you remember how we figured this one out? Well, we can use the same equation for the heat radiated by a wire that current is passing through, right? So all we need to do is square the current and multiply by the resistance. Sound familiar? Power equals I squared R. Our current is going to be 5 amps, and our resistance is going to be 75 ohms. So 5 squared times 75 is the same as 1,875. And remember that power is measured in watts. Part B. What current will be required to increase the hairdryer's power by a factor of 100? And that would make it a very powerful hairdryer indeed. So what we need to do is figure out how current relates to power, right? So let's rearrange this equation and make current the subject. I equals the square root of P on R, right? Now, if the hairdryer is 100 times as powerful, then its new power won't be 1,875, but 187,500 watts. With me so far? Our resistance, of course, won't change. So we can substitute those in. Here's our new power. Here's our resistance. Putting this into a calculator, we get a value for I, which is the square root of 2,500. And that, of course, simplifies to 50 amps. So if we increase the current by a factor of 10, we increase the power by a factor of the square of 10. We can see that with this starting equation pretty easily, right? If we increase I by a factor of 10 and we square that, then the power will increase by a factor of 100.